Hello students, now we are going to go with the next concepts, that is we are going to go with the problems on Fourier series. So before we start with the Fourier series problems, we have to go with some important results. So the results are as follows. What I have listed are very important as per the problem's point of view. Now we have seen that integration of e raised to x cos bx dx, this already we have seen it in PUC. Whenever you get a product of an exponential function and cos or sine, we should not apply u into v rule. So the standard formula for this is e raised to ax upon a square plus b square into a cos bx plus b sine bx. Similarly, when we are talking for e raised to x into sine bx, whenever we are having a product of exponential and sine function, that time need not to go for integration by parts. The answer is directly e raised to x upon a square plus b square into a sine bx minus b cos bx. These are the two standard results which are very important as per exam point of view. So to start further, next result is interval might be anything, that is c to c plus 2 pi given interval. Integration of cos nx dx for the interval of the range period 2 pi, the answer will be always 0. Same for the sine function. Whenever we are having such results, we can directly write the answer as 0. The next result is integral cos mx into cos nx dx in the range c to c plus 2 pi. The answer for these two products also will be 0. Here we are not going to apply u into v rule. Here m and n are both different and both are trigonometric functions, so we cannot apply u into v rule. Whenever the product of two functions are same, if the same functions are there, we cannot apply u into v rule. So here two trigonometric functions are there, so you cannot apply u into v rule. So when such case arises, directly you can write the answer 0 for the interval c to c plus 2 pi. Similarly for sine also the same, where m and n are not same. So the next fifth result what we'll observe is integral c to c plus 2 pi sine mx into cos nx dx. This product of two trigonometric functions where it is sine and cos, here also m and n are not same, so that time the integral value is also 0. Next, sixth result is integral c to c plus 2 pi cos square nx dx, value is always pi. Similarly for the function sine square nx dx, the value is pi. Whatever now I am listing the formulae, these are very important as per problems are concerned. Always sine n pi value is 0. Sine n pi value is equals to 0. Whatever might be n, the answer will be 0. That is sine 2 pi, 4 pi, 8 pi, 100 pi, all the values will be 0. So pi multiplied by a number, sine of that number will be equals to 0. Similarly, when we are talking for cos n pi, the answer is minus 1 raised to n. Standard value it is. Cos of n pi is equals to minus 1 raised to n. Now here n will be, now here value will be, suppose if n is even, the value will become here plus 1. If n is odd, the value will become minus 1. See now, whenever even number is there, this n will be replaced by 2n. So 2n is representing even number. So when we take 2n over here, that is even number, the answer is plus 1. For example, cos 2 pi, the value is plus 1. Cos 4 pi, value is plus 1. Cos 100 pi is plus 1. Likewise, if n is odd number can be represented as 2n plus 1 or 2n minus 1. So multiplied with pi, cos of that number is always minus 1. For example, cos pi, cos 3 pi, cos 5 pi, and so on, the value will be minus 1. So similarly, the next result is sine of n plus 1 by 2 into pi. Such results we get rare case, but whenever you get, the value of this is minus 1 raised to n. Similarly, cos of n plus 1 by 2 pi, the value is 0. Next, integration. Now we have to understand the integration of these two standard functions. This is very important as per problem's point of view. So the value of this integration of sin nx dx value is minus cos nx upon n. Whatever the multiple number is there for x, that will be coming in the denominator. Integration of sin is cos. Here nx is there, so nx upon n. We are integrating with respect to x. So whatever x with x, whatever number is there, it will come in the denominator. Likewise, integration of cos nx dx will become sin nx upon n. The next result is here minus a sine of minus n pi is always equivalent to minus sin n pi. As from the result, sine of minus theta is equals to minus sin theta. Next, cos of minus n pi is always equals to cos n pi. And those two values I have told now. Sin n pi value is 0. So whether sine of minus n pi is also equivalent to 0. Cos of minus n pi, I said it is cos n pi and its value is minus 1 raised to n. So these are the total results which you have to remember when we are talking for the problems, which are very, very important. So now to start with, we will be starting with the first problem here. So the first problem is obtain the Fourier series for the function. Okay. So obtain the Fourier series for the function f of x equals to pi minus x upon 2 in the interval 0 less than x less than 2 pi. So we have to find the Fourier series for the given function. Hence deduce that. There will be a deduction. So I will explain you how to deduce this later. First we will find what is the Fourier series for the given function. So to start, you should always check whether the given interval is of period 2 pi or no. So to check for the interval 2 pi, you have to, this is going to be the lower limit and this will be the upper limit. You have to subtract the upper limit minus the lower limit. So if you subtract 2 pi minus 0, you are getting 2 pi. Means the function is defined in the interval of 2 pi. So once you confirm it, start writing for the Fourier series in general. As we know, Fourier series for the function is f of x is given by a0 by 2 plus summation n equals to 1 to infinity an cos nx plus summation n equals to 1 to infinity bn sin nx. So this is what the general Fourier series. In this general Fourier series, you are going to compute first for a0, an and bn. So what is the formula for a0? A0 formula is 1 by pi integral c to c plus 2 pi it is actually in general. So but here in the problem it is mentioned 0 to 2 pi. So you are going to take the limits 0 to 2 pi f of x dx. Now what is f of x? F of x as per given is pi minus x upon 2. So to further, if you see there is a integration sign, so we need to integrate this function. So to integrate, what I'll do is, here 2 is whole divided, for both it is, so you can bring this 2 outside the integral. So bring that 2 outside the integral, so it will become 1 upon 2 pi, integral 0 to 2 pi, pi minus x dx. Now here minus sign is there, so integrate this separately and integrate this separately. 1 upon 2 pi as it is. Whenever we are having a constant integration, pi is constant, we know that integration of 1, integration of 1, we know that it is x, right? So integration of 2 with respect to x is 2x. Likewise, integration of pi with respect to x is pi x. So likewise, so integration of pi, I have written it as pi x. Minus sign, you keep it as it is. Integration of x is x square by 2. Limits ranging from 0 to 2 pi. So 1 upon 2 pi as it is. Upper limit, where all x is there, substitute upper limit. Where all x is there, substitute upper limit. So upper limit, when you substitute, this is x pi into 2 pi. Pi into 2 pi, it will become 2 pi square minus 2 pi the whole square, means it will become 4 pi square upon 2. This is upper limit minus the lower limit. Lower limit is how much? 0. 0 into pi is 0. 0 square is 0. Divided by 2 is 0. So, total answer 2 pi square minus 2 pi square will become 0. So, 0 into anything is 0. So, A naught value is 0. So, this way we are computing for A naught. Now, next to compute is AN. How to compute AN? The formula for this AN is 1 upon pi integral c to c plus 2 pi. Now how much you are going to take? 0 to 2 pi. F of x cos nx dx. Now 1 upon pi as it is. Integral 0 to 2 pi as it is. F of x is pi minus x upon 2 into cos nx dx. Now here whole divided by 2 is there. So bring it outside. So 1 upon 2 pi. Remains here pi minus x into cos nx. If you observe, pi minus x is one function. Cos nx is one more function. Sign between them is into. So you need to apply u into v rule. That is Bernoulli's rule. What I have stated in the previous video. So to get for the previous video, you please go through the Bernoulli's in the previous, and how to apply you will get to know here. Okay, so now we are going to choose for u and v in this. Now which is u and which is your v? Here algebraic function, same way as we consider Eilert rule. Here pi minus x is treated as algebraic function, so take this as u, and cos nx you take it as v. So to start, u into v rule. So u into integration of v. Bernoulli's rule is stated as u into integration of v. So as I have already stated, integration of cos nx is sin nx upon n minus derivative of u. Derivative of u is, now minus sign is there, so separately differentiate. Differentiation of pi is 0 because it is acting as a constant. Differentiation of x is 1. So 0 minus 1, put this it in bracket. Then 1 upon n is acting as a constant, so keep it as it is and integrate sin nx. So sin nx integration is minus cos nx upon n. Limits ranging from 0 to 2 pi. Why did I stop is because derivative of this bracket has turned out to constant. So till that the rule has to get continued. So now the derivative has become constant, so I'll stop here and I'm writing the limit 0 to 2 pi. Before you substitute the limit, simplify inside signs. Pi minus x as it is, sin nx upon n as it is, then 0 minus 1 is minus 1, minus and minus will become plus, plus into minus is, here it will become minus. So this is minus cos nx upon n square, 0 to 2 pi. Now substitute upper limit minus the lower limit. What is the upper limit? 2 pi. So where all x comes, substitute 2 pi. So pi minus 2 pi sin 2n pi upon n minus cos of 2n pi upon n square minus, here 0 now. This is upper limit minus the lower limit. Lower limit is how much? 0. Pi minus 0 is 0. Pi minus 0 into sin 0 upon n. Do not cancel this n and this n. Cannot cancel. This is an angle and this is a number. So don't go to cancel this n and this n. So cos sin 0 upon n minus cos 0 upon n square. Is it okay? Well, so once we substitute, here I told you sin n pi value is 0. So sin of 2n pi is also 0. So this whole term will become 0. Cos of 2n pi. 2n is an even number and its value is plus 1. So plus 1 upon n square is n square. Okay. Then next is sin 0 is 0 and 0 into anything is 0. Cos 0 is 1. 1 upon n square. So this is 1 upon n square. So plus into minus is minus. 1 upon n square minus 1 upon n square will become 0. So this is what your an. So an value also has come 0. Now next we'll go with bn. Bn formula is 1 upon pi integral c to c plus 2 pi f of x into sin nx dx. So here we are going to substitute f of x, pi minus x upon 2, limits ranging from 0 to 2 pi. So to start, again bring this 2 outside the integral. So 1 upon 2 pi, inside remains pi minus x into sin nx dx. Again it is a product of two functions. So apply u into v rule. So when you are applying u into v rule, again algebraic function is the first function and sin nx is the second function. So u into integration of v. Integration of v is what? Sin nx integration is minus cos nx upon n. Followed with the minus sign. In the standard rule it is followed with minus sign. Derivative of these two functions. Derivative of pi is 0, derivative of x is 1. So 0 minus 1. Minus 1 by n, you keep it as it is. Integration of cos nx is sin nx upon n. Limits ranging from 0 to 2 pi. Hence, 1 upon 2 pi as it is, pi minus x as it is, minus cos nx upon n as it is. Again, do not cancel n over here. Okay. Minus into minus it is plus, plus into minus is minus. 0 minus 1 is minus 1 and minus into minus it is plus, plus into minus is minus. So here you are going to get sin nx upon n square, limits ranging from 0 to 2 pi. So further to continue this simplification, now we are going to substitute upper limit minus the lower limit. So when you are substituting upper limit minus the lower limit, here it is pi minus 2 pi as upper limit is 2 pi. So when you substitute here 2 pi, pi minus 2 pi, pi minus 2 pi minus cos 2n pi upon n, okay, minus sin 2n pi upon n square. This is upper limit. Okay, so that is what I have substituted over here. So once we substitute, now pi minus 2 pi is minus pi, minus 1 upon n as it is, cos of 2n pi is plus 1, so 1 upon n. This quantity at least 0. Next, pi minus 0 is pi, cos 0 is 1, 1 upon n, so minus 1 upon n. Sin 0 is 0. So simplifying, you will get bn. Once we get bn, we got a0, an and bn. These all three values must be substituted in equation 1. That is what I have written the Fourier series as equation 1. So where all a0 is there, an is there and bn is there, substitute the values. So when I substitute, here a0 has come 0, an has come 0 and bn has come 1 upon n. So f of x is equals to summation n equals to 1 to infinity 1 upon n sin nx. This is the Fourier series for the function pi minus x upon 2. Now since they have asked us for deduction, I am marking this series as equation number 2. So now what we are going to do to deduce? To deduce means from this whatever series we have got from equation 2, we have to find this series. So to start to find the series, we have to substitute certain x value in this whatever final series what we have got. So when we are substituting x values, you have to choose the x values in the form of, that is x values must be 0, okay, then pi by 2, then pi in the interval minus pi to plus pi. So as per you have been given the interval 0 to 2 pi. So which value to be chosen and when to be chosen? Now here if your series is in terms of sign, if your series is in terms of sign, then compulsory start x value to substitute as pi by 2. Don't substitute 0. Why? Because 0 into n is 0 and sin 0 is 0. So what happens? The whole series will get vanished. So do not start with x equals to 0. We are going to start x equals to pi by 2. If the series is having cos term, then in that series we are going to substitute x value as 0 and start to deduce. So now here the series is sine series, so I am going to start with x equals to pi by 2. So when we are substituting x equals to pi by 2, we are going to first check whether the given function is continuous at this point or no. Continuous at this point or no means your given range is how much? 0 to 2 pi. So 0 less than x less than 2 pi. In the question they have given you the range. So whenever they are giving you the range, means less than means x will not take the value 0 and x will not take the value 2 pi. Means it is discontinuous at the points x equals to 0 and 2 pi. Means it's going to change its value. So that time we say that it is discontinuous. If it is less than or equals to means the function is continuous at x equals to 0 and it is continuous at x equals to 2 pi. Means it takes the value x value as 0 and 2 pi. That time we say that it is continuous. But when it is only less than, that time it is discontinuous. And if you observe, if you are drawing a graph over here, 0, this is pi and this is 2 pi. I said the given interval is only less than. So once it is less than means x will not take these values. But pi by 2 lies in between the range 0 to 2 pi. So the function is what? Continuous at x equals to pi by 2. So once you substitute x equals to pi by 2 in this series, we have to find for f of pi by 2 directly by taking the function value as pi minus x upon 2. That is f of pi by 2 will become pi minus pi by 2 upon 2. Simplifying, you will get f of pi by 2 is pi by 4. If it is discontinuous, I'll tell you in the other problem what to do. So f of pi by 2 has come pi by 4. Then once we substitute, go on expanding this series by substituting n equals to 1, 2, 3 and so on. So this will become 1 upon 1 sine of pi by 2 plus 1 upon 2 sine of pi, because 2 pi by 2 will become pi. Then 1 upon 3 sine of 3 pi by 2 and so on. Here summation is there, so put plus sign in between. So when you simplify, sine of 90 is 1. 1 into 1 by 1 is 1. Sine pi is 0 as I have already mentioned. 0 into anything is 0. Sine of 3 pi. 3 pi means 270. 270 value. Sine of 270 is minus 1. You can go through your calculators. 1 by 3 as it is. Likewise, when we substitute the values, we reduce. That is, we reduce the given series. Whatever the series to be deduced, we will get in this manner. So pi by 4 minus 1 minus 1 by 3 plus 1 by 5. So this way, this is the first problem on Fourier series. Thank you.